Hi everyone, thanks for coming out to hear me talk about Transmoggifying Balrog with machine learning. In this talk, I'll be introducing you to a bit about what is machine learning, what is AI, and what is the difference between these two terms, because they do get used interchangeably a fair bit. I'll also be showing you my own personal journey of exploring AI for the first time on my own, and showing some other examples of resources that are out there that can help you use AI for business or pleasure, as well as examples of things that other people have done with this kind of technology. You might be wondering, what is Balrog? Some of you have seen Lord of the Rings or Street Fighter, might have heard this name before. That technical difficulty. Can you get back to this? There we go. Balrog is the name of my cat. This would normally be the point where I introduce myself, but I'm just an ordinary domestic software developer. Balrog's the real star of the show tonight. He's been heavily involved in inspiring my first foray into AI. He's a moggy rescue kitten. He was born on the streets of suburban Spotswood. You can see here he's got a very cute little face, and I can neither confirm nor deny whether he was involved in the assassination of Gandalf. So let's start off with a bit of history of the term artificial intelligence. There's been a few different ways that this term's been defined, but essentially it's something of displaying intelligence as we would think it, like from a human, but through an artificial means. One way that this was defined is the Turing test back in the 50s. And this is the question of, are there imaginable digital computers which would do well in the imitation game? So this is not, can something have intelligence? This is, can it convince another human that human is speaking to a human? As we see here with the kitten on the payphone. You wouldn't know on the other end. Another milestone for artificial intelligence was the supercomputer Deep Blue in the late 80s, early 90s, I believe. In the early 90s, this was the first computer intelligence to win a game of chess against the current human champion. But this kind of chess approach can be done with brute force. Computers are good at performing a lot of calculations really, really fast, so you can write a computer program that works out how to be really good at chess and give the most likely outcome of winning. This is quite fundamentally different to more modern artificial intelligence like AlphaGo. So AlphaGo is Google's, based on Google's technology. They've got a machine learning program, I guess you say, that was able to use machine learning to become able to play Go against human champions. And Go is a much more complicated game than chess. There's so many different combinations of moves. It's impossible to analyze every single possible outcome and choose the best one. However, the term artificial intelligence is a bit of a moving target. It's always problems that require human-level intelligence. But what does that mean? Who defines what is intelligent? It's humans. So of course we're going to consider ourselves to be intelligent, or at least some of us. And so what gets classified as artificial intelligence has definitely changed over the years. Problems that were once considered cutting edge are now just everyday programs that can do things like optical character recognition, being able to scan in a document and be able to search for the words that were contained in it is now something that we can somewhat take for granted. As I mentioned earlier, there are these two terms that I'll quite often use interchangeably myself, of artificial intelligence and machine learning. Artificial intelligence is, at a rough idea, is tasks that we consider smart. It doesn't define anything in particular about how that's achieved. So it could be through a brute force approach. It could be through someone hiding behind a curtain. No, that wouldn't be artificial intelligence. Machine learning, however, is more specific. So this is, rather than a computer program that's programmed to do a specific task, this is a computer program that's programmed how to learn how to do a specific task. Or better yet, programmed to learn how to do tasks. It doesn't need to be specific. It can, as different algorithms and different approaches to performing machine learning have been developed, they've been able to solve more and more problems from each one through a more general solution. This means that you can have less specialization in that code and apply it to other things. So I'm going to talk a little bit about TensorFlow. This is Google's, what do you call it? Like library, environment, framework, that's the one. Framework for artificial intelligence with machine learning. And I always found it a little bit intimidating. I'd heard about TensorFlow. I'd seen a few talks from Google about it. It seemed like the welcome mat there was telling me, no, this is too complicated. You shall not get into this. But I found by going through some tutorials, there were some ways that they help out and make it so that anyone can pick it up and use it. Docker is a common tool that is used for various means in web development and such. But in this context, I find it very helpful as a contained snapshot of a computer that someone else has set up for me. Often the hardest part of trying new code with machine learning is getting the environment set up right, getting it to actually have all the dependencies it needs, all the different pieces of software, being able to integrate with your particular computer. Running it in a Docker container takes out a lot of that trouble. You might have some sacrifices on efficiency, if especially running off the computer's CPU, but it's a great way to get started. Google provides many tutorials on all the things that they do, and I was particularly interested in the TensorFlow for Poets tutorial. This was an example of using transfer learning to identify flowers. The tutorial takes you through downloading sample data of flowers, downloading the Docker image and running it, and then you train the classifier using that data. The way transfer learning works is it takes knowledge that's already been gained from previous work, previous analysis and training, and then reapplies it to a new problem. In this case, there was already a model that could do many different classifications, and that was used in addition to the data set of lots of different kinds of flowers to restructure it to be able to distinguish between those flowers. But I didn't really care much about flowers. I cared about cats. So what I had available to me is a script that I found called InstaLooter that allowed me to download images based on a hashtag. I had a list of hashtags corresponding to a couple of dozen different breeds of cat. Had access to a fast internet connection, which can be rare these days in this country. And I had one unclassified cat. He's just a moggy. His parents are just moggy cats. You know, who knows if he's got any breeding in his ancestry? Well, I wanted to know, and I didn't want to send off for an expensive genetic test. So I got 10 gigabytes of categorized cat photos and set it going. Running this on my CPU, I left it going overnight, just plugged the computer in and went home for the day. And this was doing that same training as with the flowers, but with a much larger data set containing cats. It would, of course, be a lot faster running on a GPU because the processing that you need to do for machine learning is actually very similar to graphics. So as GPUs have become more commonplace for computer games, they can also be applied to this. If you've got any kind of computer at home, it probably has a GPU capable of doing machine learning that would have blown people away only a few years ago. Google has also been working on the tensor processing unit that is specifically designed for these kind of tasks. So I took some inspiration from this relevant XKCD comic here. Might be a little hard to read the text on the screen there. This man's asking, "Oh, is this your machine learning system?" Another guy goes, "Yep, pour the data into this big pile of linear algebra, then collect the answers at the other side." He asks, "What if the answers are wrong?" "Well, just stir the pile until they start looking right." As it happened, I didn't need to stir for very long. Came up with the idea that if I could take each of Balrog's Instagram photos and run the classification on it, on the confidence that it contained a cat of each particular breed, and just add those up. And I figured that if there was, some breeds in his ancestry, then those would tend to show up higher in general. And averaged out over enough data, it would show some interesting results. This is, of course, very, very rough compared to actually sending off for a genetic test, and it's based purely on how he looks. So this was the results. We had, I was looking over them, much like he's looking over his toys that we found under the couch. These were the sums of the confidence value for different breeds, and there were a few that I could knock right out as false results. Like up here we've got the Japanese bobtail, the American wirehair. Somehow I don't think he's a Japanese bobtail with this big fluffy thing. So the conclusion I came from this is Balrog is a Turkish van. Of course, I know he's not a purebred. He's got some extra markings that are different from a Turkish van, and as I've noted down here, when I looked at this and I read up on this breed of cat, found that a lot of things correlated. He's he's intelligent. He's quite large. He's only 9 months old. And look how big he is up on the screen. Fascination with water is quite known is what the Turkish fans are known for. So even though this was quite rough, and I wouldn't be writing any nature papers on it, I found that this was an interesting result, and I'm very proud of my little boy. So I'm going to show you some other similarly fun experiments that other people have done. Who remembers Deep Dream? We did the rounds a few years ago. This was essentially taking an image classifier algorithm and inverting it, making it do the opposite process. So instead of finding things in that image, it was making the image look more like the things it was looking for. And this ended up with some pretty psychedelic results. So this photo I've run through the Deep Dream algorithm, and we've got a dog in the corner here. Balrog's not a fan of dogs. This looks like some kind of pony that's come out of his tail, and I don't know what that is, but I think I might have to take him to the vet after that. And you can actually generate these yourself. There's a website. I'll have to look that up later, but you can go to, I think it's deepdreamgenerator.com, and you can upload your own images. You can choose from a bunch of different options on which specific algorithms to use, but this is all applying machine learning that someone else has set up the computer to do. Another great example was this work by Andrej Karpathy about long-term, short-term memory networks. And what he was able to create was a general purpose next character generator. So you would give it some training data, and then it would tell you what it chose as the next character, and then the next character, and then the next character. And you'd be able to generate blocks of text. Here's some absolute nonsense mathematics that was generated from LaTeX code. Here's something that sounds kind of like it came from Shakespeare. And over here's my own application of this code, where I generated the second level divination spell for Dungeons & Dragons called Magical Fishes. You glyph darks if the one of there of the sup. I think I might have to have let that train for a bit longer before I start including it in any games. Another great example that I found someone else has done with this this network. We can. This is classical style music that was generated by a computer named Computery. I'll have a link to the YouTube video up on my Twitter, and if you're watching this talk on YouTube, in the description. He's done a lot of interesting videos about AI, but I particularly like this example. It sounded a lot worse at the start, I can tell you, before it had enough training. This was another one that did the rounds recently, the Meow Generator, where similar to the previous one of generating content, this used a generative adversarial network. I'm not entirely sure what that means, but I know that it can generate images that humans have difficulty distinguishing from real photos. And he trained it on a number of cat pictures and generated cat photos of unique cats. And these photos here are actually demonstrating that it wasn't just recreating existing photos from the training data. These ones along the top row are ones that were generated from his code, and these are the ones that were most similar to each of these. And you can see that even though there's a lot of stuff in common, there's no exact matches. So this is generating all new cat photos. The internet's going wild. So as I mentioned before, Google have provided a bunch of APIs that are really great for tinkering with machine learning, especially if you're trying to do a task that has been done plenty of times before. Mobile vision, so detecting faces and text and barcodes is fairly old hat these days, but you can get a lot more information from that face too. And this runs just on a mobile device, so an Android or an iPhone. And I find the best use of this is to actually recognize what to send to the remote APIs, because there is a bunch of those. The Google Cloud Platform has a vision API, which extends on that mobile vision to provide a lot of extra information about what emotions people's faces are displaying, whether they're wearing glasses, what color hair, all that kind of information comes out in an easy to consume form. Speech, you can recognize speech and turn that into text, which is what powers things like the Google Assistant, I'll talk about in a minute. Natural language as slightly distinct from speech, so this is taking text that might have been typed or it might have been recognized from the speech recognition and understanding what it means. So what humans are trying to communicate with the words that they're using. And this plays nicely into translation, where you take that natural language in one language and move it into another so that people can communicate without those barriers. There's also some other analysis with videos, and they're now applying this into people looking for jobs. And of course, you can just run your own machine learning. So if you set something up with TensorFlow and your computer's not powerful enough, you can run it in the cloud. Flowing on from that, conversational UI. So this is something that's been quite big this year. Things like the Google Home that's just come out here in Australia, and Amazon's Echo, I think it's called. Essentially, instead of having a visual UI, you're having a conversation. So Voice searches are now over 20% of mobile searches on Google, so people are actually using this. You're probably not seeing people out doing it on the train because people don't do it when they're out on the train. But in the privacy of your own home, it's not that bad to just go, okay, Google, show me photos of my cat. Oh, okay, Google, remind me tomorrow to take out the trash. And this is, again, all powered by that machine learning that goes into this natural language recognition that you are able to access through the APIs. And, yep, you can also make your own. So I've had a little play with this as well. Using API.ai, they've got this really simple interface for setting up what you want your inputs to be and putting in a few synonyms and different ways of phrasing it. And it will actually, when people start using your app, it'll learn from that. It'll learn from different subtle ways that people like to express a request and automatically make the app a bit more flexible. So you don't need to know how to recognize natural language with AI because someone else has already solved that problem. And on that note, I'm just going to finish up here. If you'd like to get in contact with me, feel free to email or look me up on Twitter. And more importantly, if you want more photos of Balrog, he's on Instagram. He's also got a Facebook page. He's a very social cat. And I should give a little bit of mention to the company I work for, Tubals. We're a software development agency, mainly mobile, but also IoT and other kinds of new technologies. And here we see Balrog working on our latest project. Well, thank you for listening, and have we got time for questions?